Hi, in this video I'm going to teach you step by step using the multimeter how to test power Mosfet, transistors, voltage regulators, pulse width modulation IC or power management ICs, optocouplers or opto-isolators, bridge rectifiers, Schottky diodes, and much more. And of course, I'm going to teach you how to identify the type of these ICs. Because this one, for example, is it a transistor, a Mosfet, a voltage regulator, a Schottky diode, or what? Based on what we can identify whether the component is a transistor, Mosfet, etc. So this is a free course where you will learn everything about how to test electronic component, especially the component with 3, 4, 5 and 6 terminals. So please go with me step by step and follow with me until the end of this video, and I will guarantee for you that you will be a pro on electronic component testing. So let's get started. But first, don't forget to subscribe, share the video with other people like you, and like the video, because your engagement really motivates me to create more and more videos for you. Thank you very much. And for anyone who wants to join me in the Patreon page, you are very welcome. So let's get started. So here we have basically main component, as you can see here. We have Mosfet, transistor, etc. So this one, for example, and this one, as you can see, they have the same shape and the same number of terminals. 3 terminals, 3 terminals. Okay? This one also has 3 terminals. This one also has 3 terminals, as you can see. So how can I identify these ICs? This one, this is Mosfet, this is transistor, this is voltage regulator, and this is an IC, a pulse width modulation IC that is used in switch mode power supply. So I cannot begin and test the component without knowing the type of component. For example, this is voltage regulator. I cannot test it using the same working principle as transistor. Wrong. Okay? So the first step is to know about the type of the component. Okay, so we can know about the type of component using basically 2 methods. By experience, for example, for me, when I say this number, as you can see over here, so K2611, the component that began with this number, for me, based on my experience, is always MOSFETs. Okay? And others, for example, that began with D24, as you can see, like this one, is transistor, not MOSFET. Okay? So, based on reference, for example, this type of, as you can see, component, as you can see over here, this is bridge rectifier, because here, as you can see, we have plus, minus, and we have EC symbol here. So this is simple. This is bridge rectifier. Okay? So, and other component like this, where you find 2 diodes, as you can see, like this one. Where you find 2 diodes connected together like this one. So this is a Schottky diode or a rectifier symbol. Okay? So, for example, here I have many components here. Okay, how can I see, I know whether this is transistor or Mosfet, etc. So based on two methods. So the first one is by experience. You know, using your experience, the references. The second one is to use the internet. Simple. I will give you a website, a very important website that I use in a daily basis, that provide me with all information about any component I want. So based on this simple website, the type of this IC. If you don't have enough experience on identifying the type of IC, you have to use this website. Basically, there is many websites, but for me, I prefer this website. For example, this is Mosfet. Okay, so let's confirm whether this one is Mosfet or not. We have K2611. I will show you this website in the computer and how you can find the type of the IC based on its reference. After that, I will use the multimeter to test all these components one by one. Okay, so let's go to the computer. So here, as you can see, let's go to Google, for example, and just as you can see over here, we have K2611. So let's write K2611. Okay, and just press enter. Okay, let's pick the first result. As you can see here, basically this is the website. Over here we have alldatasheet.com. This is a very important website that I use in a daily basis in order to find the type of component. So here, as you can see, we have K2611. So I can just go here. As you can see over here, we have K2611. So this is a silicon N-channel MOSFET. Okay, so I confirm that this component is a MOSFET. Okay, and I know here that this is N-channel MOSFET, not P-channel MOSFET. So if I want to download, for example, the datasheet for this MOSFET, I can just go here. This is the PDF file where we have, as you can see, 7 pages. So let's click over here and then go here. We have download and click K, the part number of the component. And as you can see, here we go. Okay, so we have the MOSFET. So I confirm that this component is MOSFET. Okay, we have MOSFET, we have gate, source, drain, and of course you can read about it, its characteristics, and of course the function, block diagram, etc. Okay, if you want to download it, you can just click over here in this icon and go here. As you can see, we have a security code for 21290 and press download, and as you can see, here we go, the file is downloaded, and then you can open it and read. As you can see, we have the file over here. So you can use this working principle for all components. So now here for this component, this is the MOSFET. So once I identify that this component is the MOSFET, then I can test it using the multimeter. Okay, so this is the MOSFET. I can test it using the multimeter and using the right method to test the MOSFET. So because this is the MOSFET, so I have here, as you can see, so this is gate. Okay, here we have drain and here we have source. If we go to the file, for example, so I upload the file. So let's go and check the file over here. So here we have gate, as you can see here, drain, source. Okay, so gate, drain, source. So now I will use the multimeter to check whether this MOSFET is good or not. So of course I will choose the diode option, as you can see. Okay, I will choose the diode option and then press the power button. So let's check. First thing to do is to connect between these two pins and these two pins in order to discharge the MOSFET. So let's test this MOSFET right now. So we know that this MOSFET is N-channel MOSFET. So the diode, as you can see here, is between source and drain, and the anode connected to the source, the cathode connected to the drain. Okay, so I will find a reading when I put the red probe in the source and the black probe in the drain, because this is N-channel MOSFET. So let's put the red probe in the source, as you can see here, and the black probe in the drain. I should get a reading about 400, 500, 600. As you can see in the multimeter, I get the reading because this is N-channel MOSFET. But if I swap the probes, as you can see, I will not get anything in the multimeter. As you can see, nothing in the multimeter. Also, between source and gate, nothing. Between drain and gate, nothing, as you can see. So the only reading is between source and drain, and when I put the red probe here and the black probe here, because this is N-channel MOSFET. Okay, so this is it for this one. Let's see another one. This time we're gonna see a transistor. Okay, so let's put the MOSFET here. Okay, so here we have transistors. Basically, for me, I know based on the part number, I know whether this is a transistor or a voltage regulator or MOSFET, no problem. But for you, the first time, you should use the part number. So, what is the part number here? We have D2499, as you can see over here, D2499. So let's go to our website and put this part number and check whether this is transistor or not. So here we have the part number. Okay, by the way, using this website, you can search using the part number, using the description, or the marking. For example, the description, if you don't know the part number, or if you cannot read the part number. For example, if you cannot read the part number is missing here, you can use the description. For example, use here N-channel MOSFET. Okay, especially for example 30 volts MOSFET, N-channel MOSFET, or N-channel 30 volts MOSFET. Okay, and then the website will give me all MOSFETs that has the voltage, the maximum voltage of 30 volt, okay, or 28 volt, etc. But the best way here is to use the part number. The best way is to use the part number. So let's go back to our component. Here we have D2499. So let's put D2499 and just hit enter. As you can see, here we go. So here we have D2499. So this is NPN. Okay, this is NPN, triple diffused mesa type horizontal deflection output for color TV. Okay, we don't have here enough information. Okay, this is NPN means transistor, because for MOSFET we have N channel or P channel, and for transistor we have NPN or PNP. Okay, so let's see this file. Also we have silicon diffused power transistor. As you can see here, we have power transistor. So let's choose this one, because also this is transistor, NPN transistor. So here we have 5 pages. As you can see, we can just click over here in the PDF file and go here, download, and click again the part number, as you can see. So let's see, here we go. We have here, as you can see, Toshiba transistor, silicon NPN triple diffused mesa type. So this is transistor, as you can see. Okay, here we have transistor, here we have base, collector, emitter. Okay, here the first pin base, collector, emitter. So this is transistor, not MOSFET, not voltage regulator. So this one is transistor. So now I can test it because I know that is transistor. So let's test it. Let's put it here. So here we have, as you can see, we have base, okay, base, okay, then collector, then emitter. Okay. So now let's use our multimeter, and of course, using the same working principle, we're gonna select the diode option, because the transistor contains diodes inside it, and just press the power button. And of course, here we have base. Using the same working principle, let's discharge this MOSFET. Okay, because when you touch the base or the gate of the MOSFET with the red probe, you will get a wrong measurement. Okay, so always try to discharge the transistor and the MOSFET and then test it. And I know that this transistor, as you can see, is NPN, as you can see here, NPN transistor. Means, as you can see here, we have here P. So means, as you can see, NPN. So let's check. Oh, we got a buzzer. Here we got a reading. Here we got a buzzer. So let's discharge again this MOSFET. Let's discharge it. Okay. Okay. So let's check again. So let's put the red probe here. We get a reading between base collector. So let's check between base emitter. We get a buzzer, a low resistance. Here we get a reading. Here we get a low resistance. So let's discharge again this MOSFET. Okay. So let's begin with the black probe here and the red probe here. We get a reading here. This is right reading here. We have a short circuit. Means this is a transistor, but unfortunately this transistor is a bad one. Okay, so this transistor is a bad transistor because we get a short circuit between base, as you can see, and emitter. Between base emitter we get a short circuit. Okay, we get a short circuit. So this one is a bad one. This is a good one. Okay, so I can't test these others, but I don't want to make a very long video, so let's pass. We gotta just test one component here, one here, etc. Okay, in order to avoid making a very long video. Okay, so here basically we have voltage regulators, but first, if I see this component, I cannot know whether this is a transistor or MOSFET. But if I look to the part number, for me, based, as I told you before, based on my experience, so for me, based on my experience, I know that 7812 CT is a voltage regulator. But let's check using our website. Okay, so here we have 78. Okay, so this is basically its part number is 7812 CT. So this is the part number. Okay, 7812 CT. So let's go to our website. Okay, here we have part number. Let's erase here and just write 7812 CT and press enter. Let's see. Here we have the same part number 7812 CT. We have 16 page for this part number, and this is 3 terminals positive fixed voltage regulator. As you can see, this is a voltage regulator. So if I want to check it or to test it using the multimeter, using the same method I used to check the transistor, wrong. Using the same method I used to check MOSFET, wrong. Why? Because this is voltage regulators. It doesn't have base collector emitter or gate drain and source. No, it has input, output, and ground. Let's see the schematic. So here we have the PDF file, 16 page. So let's download it. Here we have download. Let's click again the part number, and here we go. We have, as you can see here, the PDF file. I can even download it. Let's click here. this icon download, okay, and go and enter the security code. So we have 6175 and just click download. As you can see here, so the file is downloaded. Okay, so let's open the file. Here we go. So here we have 3 terminal positive voltage regulator. As you can see here, if you focus here, so let's remove this. So as you can see, if you focus here, let's zoom a little bit. Okay, good. Here, this is basically voltage regulator. So we have here many part numbers for this voltage regulator or series. So we have the pin 1, 2, 3, not collector, emitter, and so on. No, 1, 2, 3. So the first pin is input, the second pin is ground, and of course the second pin here is connected to the side here. Means this pin, okay, in the middle is connected to this one. We can even check using the multimeter, as you can see. So this is ground. This pin here, as you can see here, in the schematic, pin 2 is ground. This also should be ground. So let's check using the multimeter. We should get a buzzer, as you can see. Low resistance in the multimeter. So this is ground. This and this are connected. So here we have, as you can see, input, ground, and over here we have output. Okay. You can find also this type of voltage regulator. Okay. So how can we test this kind of voltage regulator? So basically, to test voltage regulator using the multimeter, you should connect voltage regulator to the motherboard, or just give it the input voltage. For example, if the input voltage is 12 volt, give to this voltage regulator 12 volt here in the input. Okay, here. So here, this is, as you can see, here we have input. Okay, so here connected to the ground, and here we have output. Okay, let's assume that the output is 5 volt and the input is 12 volts. So to check whether this voltage regulator is serviceable or not, you should power it with 12 volt in its input and connect this one to the ground, and then you should use the multimeter to check whether this you get 5 volt or not. So once you feed it with 12 volt and you connect this terminal to the ground, then you can check these 2 terminals like this and get 5 volt in the multimeter. Okay, so this is how you can check the voltage regulator. But I will give you a trick that you can use to test whether the voltage regulator is serviceable, is good or not. So how? So here we have input, ground, and output. So I can just put the red probe in the ground. Okay, the red probe in the ground, and check between ground and input. As you can see, I get a value. This is not a diode, this is a value 557. So if I move the black probe to the output, I should get a double value. So let's check. As you can see, 1190. So here we have this value. Here I should get a double value. Means this is a good voltage regulator. Okay, sometimes you can find a short circuit, means a bad voltage regulator. Okay, so this is how you can check whether the voltage regulator is good or not, using 2 methods. By applying the voltage 12 volt, for example, to the input and connecting the middle one to the ground, and you should check here or get 5 volt, or by checking using the multimeter, as I told you before, between ground and input you should find, for example, X reading between ground and output x times 2. Okay, so this is for voltage regulator. How to test TRIACs using the multimeter, step by step. So let's get started. First, let's see the definition of TRIACs. Definition. A TRIAC is defined as a three-terminal gate MT1, MT2 bidirectional AC switch that controls AC power. It is very similar to the Transistor element, but the difference between them is that the TRIAC allows the current to pass in both directions when triggered, unlike the Transistor, which allows it to pass in one direction only. It is used as a switch to control the connection or disconnection of current from a load for alternating current circuits. And the word TRIAC means triode for alternating current. TRIACs generally have relatively low current capabilities compared to SCR silicon controlled rectifiers. They are usually limited to less than 40 to 50 amps. Generally, it cannot replace SCR in high current applications. TRIACs are considered diversified capabilities because of their ability to operate with positive plus or negative minus voltages across their terminals. It can handle a wide range of currents and voltages. As you can see here, we have a TRIAC, as you can see. Of course, it has 3 pins or 3 terminals, as you can see. So this is the pin number 1, pin number 2, and pin number 3. So here we have the reference or the part number for the TRIAC. We have BTA12600B. If you have a bad TRIAC with this reference, you should replace it with the same reference, of course. Here, this part is used to connect the TRIAC with the heatsink because the TRIAC gets hot when working. So basically, before going and testing the TRIAC using the multimeter, I'm going first to show you all about the TRIAC symbols. Okay, as you can see, this is the symbol of the TRIAC. It contains 2 diodes and of course 3 terminals. So the anode, as you can see, 1, the anode 2, and the gate. Of course, you can find anode 2 or T2 or M2 or MT2. All these names means the same thing, okay? So here, as you can see, you can find also the symbol for the TRIAC. But basically, the symbol is a clear symbol. The diodes are clear. Here, the same symbol, as you can see. This is also a symbol for the TRIAC, as you can see. Anyway, it contains 3 pins. So I'm going now to show you a real circuit in order to understand the working principle of the TRIAC and how it works. This is an easy circuit that I'm going to explain to you. So basically, this is the TRIAC. As you can see, it contains 3 terminals, okay? And here we have a lamp, and here this is the DC voltage, 12 volt DC voltage. And over here, the gate is connected to a switch and to a control signal. We have 1.5 volt DC. This is a control signal. So now the switch is open, the lamp is off, okay? You know why? Because the TRIAC until now is not activated. So the current, as you can see, is not passed through the TRIAC because the TRIAC is not activated. So that's why the lamp is off. But if we close the switch, as you can see, now the control voltage 1.5 volt DC will pass through the switch and then to the gate. And then now the TRIAC will be activated. Okay? So the TRIAC has the same working principle basically as a transistor. Now the current will circulate
through the circuit and will pass through the TRIAC, as you can see, and then, of course, the lamp will be lit. Okay? So basically, the TRIAC has about 80% the same working principle as a transistor or a Mosfet. But in terms of testing, it's not like a transistor. The TRIAC testing is a very special testing. So now let's test the TRIAC using the multimeter. Okay? So we're gonna of course select the continuity option in the multimeter, as you can see. Now a good TRIAC is a TRIAC that shows 0.70 drop voltage between gate and anode 1. Okay, between the anode 1 and the gate, you should get about 0.70 in the multimeter. So let's check this TRIAC. Okay, so between pin number 1 and pin number 3, or anode 1, we should get about 0.70 in the multimeter. Of course, if you get 0.60 or 0.50, no problem, the same. So let's check. We have about 0.68, means this is a good TRIAC. Even if we switch the probes, we should get the same value as we get before. So let's check. We have 0.68. This is a good TRIAC. Okay? So depending on the type of the TRIAC you are testing, you can get 0.50 or even 0.40, no problem. So always between the gate and the anode 1, or between the pin number 1 and the pin number 3, you should get a reading about 0.70, 0.60, 0.50, no problem. But between other pins, you should not get anything in the multimeter, as you can see. Nothing between pin 3 and pin 2, as you can see. The only pins that shows the reading is pin number 1 and pin number 3, as you can see, or the gate with the anode 1. And if you get any short while testing the TRIAC, means the TRIAC is bad. Now, as you can see, every TRIAC should be connected to its heatsink because it releases heat. It gets very hot. That's why you should always pay attention. If you have a TRIAC with a heatsink, you should always use the heatsink. If you ignore the heatsink, the TRIAC can be damaged because it gets hot. Okay? As you can see, we have the TRIAC now is connected to the heatsink, as you can see. To talk about how to test the Schottky diodes. So we find the normal diodes in the primary stage of every flyback power supply and the Schottky diodes in the secondary stage of any flyback switch mode power supply. Of course, as you can see here, this is Schottky diodes with two diodes connected together. Here also we have another kind of Schottky diodes with just two leads or two terminals, as you can see. And over here we have a Schottky diode with three terminals, as you can see, connected to the motherboard. And this is its heatsink because this kind of diodes gets hot. That's why we have the heatsink here. Always you should differentiate between normal diodes like those diodes as you can see here and Schottky diodes. Okay, so here this is just a general purpose diodes or a standard diodes, and this is the Schottky diode. Okay, so I'm going to show you the differences between standard diodes and Schottky diodes. So we're gonna use the multimeter to test these diodes, and we're gonna select the diode option in the multimeter. So let's begin first with testing a normal diodes or a standard diodes in order to see the difference between both. Here we have a 500 drop voltage. Okay, so let's check the other diode. So as you can see, we have about 500. The drop voltage or the reading is about 500 for standard diodes. But for the Schottky diode, as you can see, let's check the drop voltage. As you can see, we have a low drop voltage. So the Schottky diodes always give a low drop voltage. Okay? That's why you should never replace a bad Schottky diode with a normal diode or a standard diode. Never. Because if you change or replace a bad Schottky diode with a standard or a general purpose diode, it will be damaged immediately. Because the Schottky diode is a fast switching diode with a low drop voltage. Okay? So here, this is another flyback motherboard, as you can see. This is the primary stage, as you can see, where we have the fuse and electromagnetic interference. So those diodes are normal diodes, and over here we have Schottky diodes. As you can see, we have two Schottky diodes, one with two leads, as you can see, and the other mounted to the heatsink with three leads, as you can see. So let's check these normal diodes also. We have about 500, the reading or the drop voltage. Let's check the second one, the same, about 500. This is a high drop voltage basically, but if we check this one, this is the Schottky diode with 3 terminals or 3 leads. So we should find a low drop voltage. Here we have its terminals, as you can see in the back of the motherboard. Okay? Basically it contains 2 diodes inside it, so we're gonna check 2 diodes. The same, the first diode we have 128. The second diode about 128, so this is a low drop voltage. So this is a good Schottky diode. This is the Schottky diode shape. It contains 2 diodes connected together with their cathodes, as you can see. So always when you test the Schottky diode, you should get a low drop voltage. If you get any continuity or buzzer, means the diode is damaged. Here we have the second diode. This is a good Schottky diode. This is how you can test it. If you get any buzzer or any continuity, means failed. Automatically you should change it. Let's check this also. We have another one with the same working principle. Basically, it contains 2 diodes inside it. Here we have its reference or part number. This is MBR 2010. So let's check it again using the same working principle. The first diode we get about 130, good, low drop voltage. We have 135, a low drop voltage. This is another good Schottky diode. Okay, so this is how you can check this kind of diodes. Show you how to test bridge rectifiers step by step. So as you can see, the bridge rectifier contains 4 pins. Here we have plus, okay, here we have EC, these 2 terminals, and here we have minus, okay. So the same for all bridge rectifiers. As you can see, it contains 4 pins. So I'm going to show you step by step all about bridge rectifier testing. Okay, so here also you can find a bridge rectifiers like that, just 4 diodes separately. Okay, as you can see, we have 4 diodes in the circuit board. So I'm going to show you how to test these 5 bridge rectifiers step by step in order to master the bridge rectifier testing. So of course we're gonna use the multimeter and we're gonna select the diode option because the bridge rectifier contains 4 diodes inside it. So let's begin with this bridge rectifier. As you can see, we have here minus and here we have EC and plus. Always this edge, this cutted edge like this means the positive terminal. Okay, so here this is the reference for this bridge rectifier if you want to change it, to replace it. So to test the bridge rectifier, you should put the red probe of the multimeter in the minus, okay, and check with other pins. Basically, you should find a reading between these two leads, also the same reading between the two leads, and between minus and plus lead you should find the double reading or double drop voltage, as you can see. Okay, so if we swap or switch the probes, we should not get anything. So nothing here, nothing, and also here nothing, means this is a good bridge rectifier. Okay, you can also check it by putting the black probe in the plus terminal. Here we get a reading about 600. Here we should get about same reading, 600. And here we should get a double reading or a double drop voltage. Means this is a good bridge rectifier. So let's check these two rectifiers also using the same working principle. Here we have minus. Let's put the red probe here in the minus. Here we should get a reading about 500, good. Here also we should get the same reading about 500. And here a double reading or a double drop voltage. So this is a good bridge rectifier. If we switch the probes, we should get nothing. Nothing here, nothing here, and nothing here also. Means this is a good bridge rectifier. Let's check this also using the same working principle. We have the minus here. We should put the red probe in the minus. We get a reading. Okay, here also we get a reading about 800 or 600. Here, double reading. This is a good bridge rectifier. If we switch the probe, of course, nothing here. We should get nothing and nothing. Means this is a good bridge rectifier. Right now, let's check these bridge rectifiers. In the circuit board, we have just diodes. So basically, you can check this bridge rectifier using the same working principle or using another method that I'm going to show you. Here, as you can see, we have diodes here. We have 4 diodes in the back of the circuit board. So here, as you can see, we have anodes. This is the anode connected to the anode of this diode. Means here we have the minus or the negative terminal. Here we have minus, 2 anodes connected together. Okay, and here we have cathode, as you can see, connected to cathode. Means here we have plus. Okay, exactly the same as this bridge rectifier. Here we have plus, means 2 cathodes connected together, as you can see in the symbol. Here we have minus, means 2 anodes connected together. So to check this bridge rectifier, we can simply check separately each diode. Here, this is a good diode. Let's check the second one. Here we get a reading. If we swap the probes, no reading. So here we get a reading. If we switch the probes, no reading. This is a good diode. For this also, we get a reading here. If we swap the probes, no reading. Means this is a good diode. Means a good bridge rectifier. We have also here 4 diodes. Means a bridge rectifier here composed of 4 diodes, as you can see. To test this bridge rectifier, you can simply test the diodes separately, as you can see here. Okay, so let's test the first diode. Of course, you should put always the red probe in the anode and the black probe in the cathode. Okay, so let's check the second one. We have a reading. If we switch the probes, we should get nothing. Nothing means this is a good diode. Let's check the third one. We get a reading. If we swap the probes, no reading. This is a good diode. The last one, we get a reading. If we swap the probes, no reading. Means this is a good diode also. And if we test optocouplers or opto-isolator using the multimeter. So I'm going to show you how to test a 4-pin optocoupler and a 5-pin or 6-pin optocoupler. So basically this is the circuit diagram of the 4-pin optocoupler. Here we have a 4-pin optocoupler, as you can see in the motherboard. It contains 4 pins, as you can see. Okay. So this is the pin number 1, always marked with a white mark or a hole here. Here also we have another type of optocoupler, as you can see, with 4 pins. This is of course the pin number 1, okay? Pin number 2, 3, and 4. So this is the circuit diagram for 6-pin optocoupler. As you can see, it contains 6 pins, of course. Here we have a real optocoupler IC, as you can see, with 6 pins. This is its reference, okay? So let's begin with 4-pin optocoupler or opto-isolator. As you can see, we have pin number 1, number 2, number 3, and number 4. So basically, this optocoupler contains 2 components inside it, an infrared diode and a phototransistor. So pin number 1 connected to the anode and pin number 2 connected to the cathode of the diode. And over here, as you can see, the pin number 4 connected to collector. Here we have collector, and here we have emitter. So this is the same for all optocouplers with 4 pins. The same schematic. Always pin number 1 connected to anode, pin number 2 to cathode, pin number 4 to collector, and pin number 3 to emitter. So let's test the 4-pin optocoupler. So of course, between pin number 1 and pin 2 of the optocoupler, we have a diode. So if we test between pin number 1 and pin number 2, we should get a drop voltage about 1000, okay? And between pin number 3 and pin number 4, of course, we should not get anything in the multimeter, because always between collector and emitter, for every transistor, if you test it, you will not get anything. So of course, we're gonna use the multimeter and we're going to select the diode option because we're going to test the diodes, okay? So let's test this optocoupler, as you can see. So always you should first locate the first pin, okay? Pin number 1. So pin number 1 connected to anode and pin number 2 connected to cathode. And of course, pin number 3 and pin number 4 connected to the phototransistor, to the collector and emitter of the phototransistor. So let's check right now this optocoupler using the multimeter. So let's put the red probe in the first pin, the anode, and the black probe, of course, in the cathode. We should get about 1000, a drop voltage about 1000, as you can see. In the multimeter, we have 1100, means this diode is a good diode. So if we swap the probes of the multimeter, we should not get anything in the multimeter, okay? So let's check. As you can see, we get nothing in the multimeter. Means the diode inside the opto-isolator is a good diode. Now let's check the phototransistor. Of course, the pin number 3 and pin number 4 connected to the phototransistor. We should not get anything in the multimeter. As you can see, nothing means the phototransistor is not shorted, is a good transistor. Means the whole optocoupler is a good optocoupler. So if you get any short between the optocoupler terminals, means the optocoupler is bad. So if you get a short between the pin number 1 and pin number 2, or pin number 4 and pin number 3 for the transistor, means the optocoupler is shorted. You should replace it with another optocoupler with the same reference. So let's check now this optocoupler. As you can see, using the same working principle, of course, we should always locate the pin number 1. So let's put the red probe of the multimeter in pin number 1 or anode and the black probe in the cathode. We should get a reading about 1000, as you can see, 1100. So this diode is a good diode inside the optocoupler. So if we swap, of course, the probes, we should not get anything in the multimeter. As you can see, nothing. Means this diode is a good diode. Now let's check the phototransistor in the other side of the optocoupler. Of course, we should not get anything between pin number 3 and pin number 4. Because if you check any transistor between collector and emitter, you will find an open circuit. So here we have 1 in the multimeter. Means the transistor is good. Means the whole opto-isolator is good. Okay? So this optocoupler is a good optocoupler. So of course I want to add that if you find any short between optocoupler pins, means the optocoupler is shorted. So you should never find a short between pin number 1 and pin number 2 and pin number 3 and pin number 4. Now we're gonna see how to test the 6-pin optocoupler. So basically this is the circuit diagram, of course, of 6-pin optocoupler. Okay, here we have the diode and the phototransistor. As you can see, the same as the optocoupler with 4 pins. So the pin number 1 is connected to anode and pin number 2 connected to cathode of the diode. Exactly the same as this optocoupler. Okay, always pin number 1 and pin number 2 connected to the diode or to infrared diode. So here pin number 4 and pin number 5 connected to the phototransistor. So pin number 4 connected to emitter and pin number 5 connected to collector. And of course the pin number 3 and pin number 6 are not used. No connection. In C means no connection. And sometimes in some optocouplers you can find that the pin number 6 is connected to the base. Okay? So sometimes the pin number 6 of a 6-pin optocoupler is connected to the base. But you can discard it. It's not important. Important thing is the diode and the phototransistor. Okay? Here as you can see we have the optocoupler that we're gonna check. Its reference is CNY17F-2, as you can see. Always this age means the pin number 1, as you can see. This is pin number 1, 2, 3, 4, 5, and 6. Okay? So always the pin number 1 and pin number 2 connected to the diode. This is connected to anode, the pin number 1, and the pin number 2 connected to the cathode of the diode. So we're gonna check this optocoupler, and of course we're gonna check the pin number 1 and pin number 2 where we have the diode. So we should get a reading about 1000 drop voltage, the same as the optocoupler with 4 pins. So let's check. We're gonna put the red probe in the pin number 1 and the black probe, as you can see, in pin number 2. We should get a reading, as you can see, about 1150. This is a good diode, basically. So if we swap the probes, we should not get anything in the multimeter. So we're gonna put the black probe in the first pin and the red probe in the second pin. Here we don't get anything in the multimeter, means the diode inside the optocoupler is a good diode. Now let's check the other side where we have the phototransistor. So basically the phototransistor we're gonna check between collector and emitter. So pin number 4 and pin number 5, as we have in the schematic. We will not find anything, no reading in the multimeter, means the phototransistor is serviceable, is a good phototransistor. And of course this means that the optocoupler is a good optocoupler. Okay, so you can look for the datasheet for any optocoupler you want. For example, let's search for the datasheet of this optocoupler, a 6-pin optocoupler, CNY17F-2. So you can just pick the first result. As you can see, we have datasheet. Okay, and here, of course, this is all datasheet website where we have datasheets for integrated circuits. Here we have, as you can see, the 6-pin optocoupler for power supplies. Here we have the same part number or reference, as you can see, CNY17F-2. So you can just click this PDF file to download it. And then, as you can see here, you can click download over here, click the reference, and here we go. We have the file, as you can see. So this is the file, the 6-pin DIP optocoupler for power supply applications. So of course, to download this PDF file, you can just click here. Here we have description, features, applications. As you can see, we have power supply regulators. It can be used for digital logic inputs, microprocessor inputs, and so on. And this is the schematic, as you can see, the same schematic as we have seen before. The pin number 1 connected to anode, the pin number 2 connected to cathode, as you can see. Pin number 3 and pin number 6 are not used, and of course pin number 4 and 5 connected to the phototransistor.